Hey guys, in this video I will be showing you how to create short and long videos fully automated using N8N without paying a single dime. Let's begin. First of all, as you can see here, this is the workflow that I have created in order to achieve that. So as you can see and notice, it is divided into three parts. The first part is responsible of generating video settings and script. So we are starting with our trigger, which is a on-form N8N trigger. So to get this, just right click on add node, look for form, and then select the N8N form. Under triggers, include the onNew N8N form event. It will give you something like this. You will have, of course, to configure your form. So for our case, we'll be going with the form title. We give it a form title for video generator. We have our form elements, which are the elements that are going to be included in our form. So for the first field, which is the idea, in which the user will type in what video he wants. So it is element typed text, and the field is required, of course. The second element, which is the style, again, the element type is text and it is required. So the style is basically the images style or the style of the images that are going to be generated using AI. The third field, which is the tone, it is the tone of the script. So let's say storytelling, explainer, whatever tone you want. The fourth field, which is the voice, this one will be, of course, linked to our free TTS model that we're gonna use, which is Kokoro. We will get to that, of course, later. So for this, I have prepared a list of all of the voices that are available in Kokoro TTS. So I spent quite a lot of time like manually copying and pasting the voices. After that, we have another field called type. So the type will be chosen between long form and short form video. That way we can distinguish the resolution that we'll be using in our videos. And now we have the music URL, which is basically the ID of the music video or the music that we're gonna include as background music to our videos. It is gonna be from YouTube, of course. When you go to YouTube, I will show you later how to get the ID of the video when demoing this workflow. And then we have finished with our form trigger. Just before we continue with the rest of our workflow, I just wanted to let you know that we need some things to be installed in order for this workflow to work. The first thing is, of course, N8N needs to be self-hosted. I have previously made a video on how to do that. I will leave you guys the link in the description. The second thing will be the TTS model or the Voiceover model we'll be using, which is Kokoro TTS. We will need the NCA Toolkit and MinIO. So the NCA Toolkit will be responsible of captioning, animating the images. MinIO will be our storage for this video. Now I have recently noticed that MinIO have changed their UI and their solution. Apparently you will not find it same as the tutorial I have previously made. So I will leave you guys the link in the description, of course, for our community to join, in which you will find the assets on how to deploy MinIO and NCA Toolkit. It will be a fully textual guide. And of course I have made a video on that also. After that, we will need a free image generation model, which is in our case will be Flux Schnell through the Together AI API. For this, we also made a video on how to use Together AI to get Flux Schnell model. I will leave you also the link in the description, but just a quick rundown, you will have to go to your models here inside Together AI, of course, log into your account, and then go scroll a bit down until you find the Flux.1 Schnell free. Just click on it, then go to open in Playground. After that, look for API view. Go to curl and then copy your curl request, and then you will be pasting it into HTTP request later on. And keep in mind, you will have to get your API key from Together AI as well. Just go here, go to settings, go to API keys, and then either add a key and generate a new key or copy your old key if you have created one already. All of this will be in our community, which is free, by the way. As you can see here, it is currently sitting at 139 members. We have multiple resources for our previous videos in which we share a Notion file containing all the scripts, all the HTTP calls, the prompts we are using in our videos. So yeah, moving on. Now we will go to our second node, which is a code node made to determine the resolution for our video. So if we open it here, we are taking the type from the form submission here, just to know whether the user has chosen the short form or long form type. Based on that, of course, we have for the long form, the width and height. As you can see here, we are trying to get the best width and height for each type of video, while staying between the recommended values for our Schnell model, because it doesn't require higher than this value here. So we are playing with that to get the best quality. And we'll be outputting the width and height that we're gonna use later on in our image generation. After that, we are using a basic LLM chain. Just right click on add node, look for basic LLM chain included. Here we are gonna be passing to our LLM model the idea that the user inputted in the form. Just drag and drop here. the style again, drag and drop, and the tone. We are gonna click on add prompt and add a system prompt just like this. I will input it in our community asset, of course. So we are basically telling it that is a creative assistant that will provide an output just like this. So given a unique title to our video, given the different scenes with the ID, the transcript for that scene, and the image prompt that will be generated for that scene. We need to link it to a LLM model. So for this, click on add chat here. You'll have a list of LLM providers that you can choose from, either OpenAI, Mistral, Grok, or whatever. I went with the Google Gemini chat model 1. So I'm using the Gemini 2.0 Flash model. Again, you will have to input your credential here. Just click on create new credential and input the API key you got from Google AI Studio. I have already done that, so I'll be moving on. Going back to our basic LLM chain, we'll have to turn on the require specific output format. That way we are taking the output that we have specified here and trying to like parse it into an actual JSON object. So once you do that, this message will pop out. Just click on the output parser. It will give you 3 options that you can choose from. I went with the structured output parser. And then for the schema type, you will have to put generate from JSON example, and you will have to input a simple or a sample JSON example based on your structured output that you have specified in the prompt. So I have given it this example here. Of course, this one will be also available in the community, so you can just copy and paste and put it here. All right, after that, since this LLM chain will be generating the JSON output, which is the list of, let's say, video scenes and the title of the video, we need to, as you can see here, it is one item. We need to split it out into the different scenes. We'll treat each scene in isolation, so on its own. For that, we'll use the split out node. Right click on add node, look for split out. Once you open it, you will have to drag and drop the output.scenes into the fields to split out. So from the output of the basic LLM chain, just take the scenes here and drag it and drop it there. For the include, just select the include all other fields. Now we will move on to the create scenes part. This one will be treating the different scenes in isolation, of course, and generating the image, the voiceover, combining the audio and the image together, and then uploading it into the bucket. So we are going to start with the loop over items node. That way we can take all the items that we got from the output of the split out node and then iterate over them. So for this, again, add node, look for loop, and select the loop over items node. When you click it, just remove all the other parts and keep the node itself. It will have 2 outputs, the done output and the loop output. We'll start with the loop output, so keep the batch size here to 1 and leave it as it is. And then link it to a wait node. That way we can control the rate limiting, because we are using Together AI. And using Together AI with the Flux Schnell model allows only for the generation of 10 free or 6 actually free images per minute. Right click on add node, look for wait, and then click on it. Once you include it, you will have to set the wait amount to 5 and then tune it to seconds. All right, link it to the loop node through the loop output, and then we are gonna use the HTTP request to generate the images. So for this, just click on add node, look for HTTP request, include it. Once you do, of course, you will have to go to your Together AI website and then select the Schnell model as I showed you before. In the API view, just go to curl and then copy this one here. Go back to the HTTP request, click on import curl, and then paste in your request that you have copied from the website. It will give you something like this. Of course, you will have to still configure it. So first of all, the model is post if you want to do it from scratch. The URL is just this URL here. For the authentication, it will be empty if you have copied your curl. It will be like something like this. In the headers, it will give you authorization and bearer/Dior token. So you'll have to turn this off and then go to authentication. It will be none. Just select generic credential type, header auth, and then it will tell you to create your new credential. Just click on create new credential, and then for the name, put authorization, and then for the value, put bearer space, and then paste in your API key that you got from Together AI. That way you will not have to do it every time you use the Together AI API. You just have to select it from the authentication like I did here. And then it will be hidden, of course, if you're doing a tutorial on YouTube. Nobody else is going to be able to see your API key. Now we'll move on to the body part, which is the send body, of course, activated. The body content type, select JSON. The specify body, select using JSON. And then for the JSON request, you can copy it from my community. We are basically using these inputs here. So the model, which is Flux.1 Schnell, which is the free one. The prompt will be taken the image prompt that the basic LLM chain has generated. So just go back to since we are looping over each item generated by the basic LLM chain. So we are taking this from the loop over items. Just select the image prompts and drag it and drop it between the two codes here. For the width, we are gonna take it from the code node that we have inputted to determine which resolution we're gonna go with. So if we scroll down a bit here and the determine resolution code node here, we have the width and height. Just copy the width here, not copy it, actually drag it and drop it. Same for the height. For the response format, it has to be base64_JSON. That way we can turn it later on into binary and we can download it or upload it into our MinIO bucket. Alright, we are done with the image generation HTTP request. Now we have to turn the base64 JSON into the binary. So right click on add node, look for convert, select convert file, and then under the move base64 string to file, just input it here or select it. It will give you something like this. You will have to select the base64 input field, which will be from the output of the HTTP request here. I have like changed something, that's why we can see the output of it in here. It is pretty the same, just drag it and drop it. It will be B64 JSON from the output of the Together AI HTTP request. Keep the put output file in field data. The output will be this binary. We can like view it or we can download it. We'll not be doing that. Now we are going to upload it into our MinIO bucket. Right click again, click on add node and look for S3. Select the S3 here and then select the upload a file action. For this, of course, you will have to input your credentials that you have put inside MinIO. All of this will be in the assets of my community and the previous video I have done, so I'll not go through it again. For the resource, keep it to file, operation upload, the bucket name, which will be NCA Toolkit for my case, because I have created a bucket inside MinIO that has the name NCA Toolkit. It can be whatever for you. If you have changed the name of your bucket, so feel free to input it here. For the file name, we'll be given it actually a combo of the unique title generated by the basic LLM chain and the ID of the basic LLM chain or the scene that we are in. So if we go to schema here, we are gonna look for the loop over items. Just select the unique title, drag it and drop it here, and then select the ID, drag it and drop it after, and add .jpeg, which is the output format of Together AI Flux Schnell. Activate the binary file, and then for the input binary field, select data. Alright, we are done uploading our image. Now we'll move on to generating the voiceover using the Kokoro TTS model. So this one will be also HTTP request. For the method, it will be post. For the URL, it will be HTTP localhost 2.8880/v1/audio/speed. If you have deployed N8N in Docker and the Kokoro model in Docker, localhost will be changed with host.docker.internal. For my case, N8N is not on Docker and Kokoro is on Docker, so I'm using localhost here. Authentication, we don't need it. We need only the send body, JSON, and using JSON for the specified body. For the JSON here, it will be something like this. So for the model, we'll be using Kokoro. For the input, which will be the transcript that we got from the split out node, or we can actually use it from the loop over items node. It's the same. So for the split out node, just drag and drop the transcript from the split out node or from the loop over items node and put it inside the double quotes here. For the voice, we'll be taking the voice we have selected in our form submission. So if we go and scroll down a bit here, we find the form and take the voice from here and put it inside the double quotes. Response format, put it to MP3, and then the speed to 1. Alright, we are set now. This one will be responsible of generating the audio. It will give us back a binary file that we are gonna also upload into our MinIO bucket. So S3 again, look for the upload file, keep the file resource to file, operation to upload, the bucket name same as the bucket name you have used or created inside MinIO. For the file name, again, we'll be using the same structure that we have done before with the previous upload. So the unique title from the loop over items and the ID from the loop over items. Just like this, drag and drop here, and then add .mp3 since our extension or file will be .mp3. Activate the binary file and then input binary field. It will be data, same as the name of the binary that we have outputted from the Kokoro TTS model. Now we have generated the audio. We'll need to know the duration of that audio. That way we can like trim our animation or the image later on to fit exactly the time of that audio. So we'll be using an endpoint from the NCA Toolkit, which is the /v1/media/minimum metadata. Localhost again because N8N is deployed locally, not on Docker, and then NCA Toolkit is on Docker, so it's localhost. If both N8N and NCA Toolkit are on Docker, so we'll be using host.docker.internal here. Again, the authentication same as I did in the video. If you follow the previous video on the assets, you'll figure out on how to do this. But we'll need the send body. So the body content type to JSON, the specified body to using fields below. We'll need one parameter, which is the media URL, which is actually the URL of the audio that we have generated or uploaded inside MinIO. So for this media URL, we'll start with a prefix http host.docker.internal because NCA Toolkit and MinIO are both on Docker. 2.9000, which is the port for the MinIO server. The NCA Toolkit is the name of the bucket we have created, and then the name, which will be the same structure as we have inputted previously, so the unique title and the ID of audio, and then the .mp3 extension. This one will output something like this. We'll be only interested in the duration here. That way we can trim the video exactly to fit our duration of the audio. So we'll use it later on in the animate image. So for the animate image, again, it's an endpoint from the NCA Toolkit. The endpoint is v1 image convert video. The authentication is the same. The send body will need a JSON and using JSON in the specified body. For the parameters, we need the image URL, which is the image that we have generated using Together AI and we uploaded to MinIO. So again, the same prefix here, the same name of the bucket where we uploaded our image, the same naming structure, which is the unique title of the video and the ID of the scene, and then add .jpg or JPEG. For the length, we'll be using the duration we got from the previous get audio duration HTTP request. So we'll take the duration and drag it and drop it here in front of the length. The frame rate will be using 24 frames per second. The zoom speed, we can of course adjust it. I keep it to 2 seconds because I feel like it's the best. Alright, we are now done with animating our images. We'll be adding like a slow, smooth zoom in effect to match the vibe. And then we'll pass to mixing the audio and the video. We have the same duration for the voice and for the image. And then we will mix them together using the execute command node inside N8N. So look for execute and then select the execute command node. It will give you something like this. Select the execute once and then you will have to copy this command here. I will put it inside the assets in our community, of course. This one will be mixing the audio and the video, which is the image animated. To create the scene video, we'll be using FFmpeg. I have also in my community made an asset on how to download FFmpeg, and I have used it in previous videos, so feel free to watch them. You'll know how to use it, of course, and download it. So FFmpeg here. Then all these arguments, basically we are inputting here the video and here the image. Both are using the URL of the MinIO where we uploaded the image and the audio for that scene. And then we are selecting the name of the output file, which is the same structure again. So basically the unique title and the ID.mp4 for each scene. That way we can know and predict the names later on and concatenate them into one single video. So after that, we are gonna use the read files from disk node. So look for it here, select it. Select the read files from disk, and then we'll have to put the same name that we have put as an output in the previous node. So the unique title and the ID.mp4. We're gonna load it, that way we can see the binary of that file, and then we are gonna upload it inside MinIO. So again, the S3 node, the NCA Toolkit bucket name here, the upload operation, the file name, which will be the same structure as we did always. So the unique title, the ID of the scene, and then .mp4. That way we upload it inside MinIO under the same structure. Every file we had will be inside our MinIO bucket. So after that, we'll have to link this output of the S3 node with the start of the loop over items. That way we know that we are iterating over and doing this process for each scene here until we finish all the scene. So once we finish the scene, we'll take the output done and link it to a code node. That way we'll prepare like the list of video URLs from MinIO. So for each scene, we have created a final video containing the voiceover and the image and animated and uploaded all of them to MinIO. So now we are gonna take all the URLs and then parse them into like a single object here. So we are taking them, we're constructing the video URL array containing the video URL and the URL of that video scene for each scene, of course. And then we are returning them. We are using a set node. To use it, right click on add node, look for set. Select the edit field set. click here, add a field called JSON, and then drag and drop the output, which is the videos from the previous code node, and put it here. You will see the output will be something like this. The video URL for the scene 1, scene 2, scene 3, etc. And then we are gonna take all these URLs and put them inside the NCA Toolkit concatenate endpoint, which is a /v1/video/concatenate. The authentication will be the same. We'll need the send body using JSON at the specified body. For the JSON, we'll use the video URLs. So the video URLs, and then we will drag and drop the array we got from the set field node. So the JSON here, drag it and drop it there. Alright, this one will be combining all of the videos that we have created for each scene and then put them into a final video. After that, we'll take that final video and create captions for. So we'll use the caption endpoint from the NCA Toolkit, the method post. The send body will be JSON as content type, specify body using JSON, and then this body request here. Of course, this is fully customizable if you want to change like the coloring, the position of the captions or whatever. Just for the video URL, you'll have to input the video URL from the previous node, which is the concatenate scenes. So that's HTTP request will return a response, which is the URL of the final video without the caption, and we'll take it and drag and drop it between the two codes here. These are all customizable, like the coloring, the line color, the word color, whatever. The assets will be in our community. Feel free just to copy and paste them and try with different like combos. After that, we'll be adding some background music to it. Remember the music field that we have inputted in our form. We'll be taking it now and downloading that YouTube video to download the music using the YouTube-DLP command, which is a library you need to install using pip install YouTube-DLP. You will have to have Python installed in your local machine. Now we'll have to give like a name for our output. We'll be using the same ID that we got from the form submission node, which is the music URL. After that, we'll have to input the link of the YouTube video. So for my case, I have prepared the prefix since I'm inputting only the ID in the form. So I prepared the prefix here, youtube.com/watch v, and then equals. And then after the equals, we'll drag and drop the ID that we got from the form submission node. So music URL and put it here. Alright, now we have downloaded the video. We'll have to load it inside N8N to get the binary. Read files from this node. File selector, it will be the same as the output we have specified. So it will be the ID of the YouTube video. Same here. It will be the ID of the YouTube video. So music URL from the video request form submission. Add.mp3. That way we know we are getting the correct file. It will output like this data binary field that we are gonna take and upload inside MinIO using the upload file from MinIO, NCA Toolkit bucket name, and then the file name will be taken directly from the previous node, which is the load music. So take the file name and drag and drop it here. Keep all of these as they are. After that, we'll be using the execute command node again using FFmpeg. That way we'll pass the fully captioned video. As you can see here, I'm replacing the host.docker.internal with localhost because MinIO is in Docker and my N8N is not on Docker. So if I have N8N on Docker, I will not be needing this replace function here, so I'll keep it as it is. For the music, will be taken the music we have loaded, or the file name we have loaded from the load music. So this one, drag it and drop it here. All of these arguments to specify the volume and specify that it will loop, etc. And then we'll give a final name to our video, which is the unique title, basically that we have generated using the basic LLM chain, and then add underscore final.mp4. And then we'll take it and use the read files from disk. That way we can load it. So take the same name, add underscore final.mp4, and we'll get the final result of our video. Let's execute together now and see what it gives us. In the URL part here, just copy this ID under the equals, or after the equals, just copy it and paste it inside your forms. For the idea, let's say horror story of the monkey. For the style, let's put pixel art. For the tone, horror storytelling. For the voice, we'll be selecting the voice that we're gonna use. So let's go with, let's say, Adam. For the type, we'll be generating a short form video. For the music URL, just paste in the ID there, click on submit. Just a reminder, this is just a basic workflow to get it working. Of course, you can take it a step further from this and customize even more either the prompts, the outputs, and make it even better with a prompt, like add extra things like auto publishing to YouTube or Instagram or TikTok. And yeah, let's see what our workflow will give us in a second. All right, and as you can see here, our workflow has finished generating. So it took like roughly 5 minutes to finish all the scenes and images and voiceover. I have added like some extra delay here because I got an rate limit error because I used to have 5 seconds, which apparently weren't enough to bypass the rate limiting. So I changed this to 15 seconds. And then we got our video. So let's take a look at it. If we open this node, let's click on view.
The old paw rested on the dusty shelf, a silent promise of twisted fate. A weathered hand reached out, ignoring the chill that filled the room. "I wish for wealth," he croaked, clutching the paw tightly. The next day, news arrived. His son crushed in a factory accident, a settlement paid in blood money. Despair consumed him. "I wish my son back," he screamed into the night. A slow, deliberate knocking echoed from the front door. He fumbled with the paw, his last wish a desperate plea. "I wish him gone." The knocking stopped. Silence. Only the chilling realization of a price too high remained.
So yeah, we got a pretty decent, let's say, short. But yeah, this is just a basic workflow on how to generate videos using the Flux Schnell model, which is free. So the quality is not so good, but not bad at all for a free model. I'm pretty sure if you use like a paid model, the quality will be much better. But this one is doing the job currently. So yeah, it gave us a pixel art. The audio is good. The captions are good. We got our background music. And yeah, what you can do is improve on maybe choose a different or a better image generation model and tweak it. And tweak the prompts a bit more. I hope you guys enjoyed and found this video useful. As I said, the assets for this video will be included in our community a day after this video gets uploaded to YouTube. So yeah, I hope you guys enjoyed and found it useful. If you did, please leave a like and subscribe to the channel, and I will be seeing you in the next tutorial. Goodbye.